So when we have triangles and I don't have a right angle, I still want to be able to find the sides and the angles. So there's no right angle here, so I can still find all of the sides and all the angles. And we're going to use something called law of sines. And you're going to like this because I'm really not lying. This is easy. You're going to like it. Okay, so first of all, the first thing is when I draw a triangle, the angles are capital letters. So A, B, and C, those are the capital letters. And the side across from the A, it's a lowercase a, and that's side A. Across from C is a lowercase c, and across from B is a lowercase b. And that's how we're going to label all the time, okay, just for convention. So the law of sine looks like this. So they're proportions, which is why you like, because this is just a cross multiply. So it's sine of A over side A, sine of B over side B, and sine of C over side C. Okay? Now, there's two cases where we can use this, and it's super easy. So if you look, I have an angle, and a side. Right? Does everybody see this? Angle, angle, side. Angle, angle, side. So when you have angle, angle, side, we just have to figure out which side I'm looking for or which angle I'm looking for. So in this case, they are looking for the side across from the 104, correct? So I want sine of 104 over x. And that's going to equal, I have sine of 47 over 15. And so to find x, we're literally cross multiplying. So everybody do that. And when you cross multiply, make sure you get the same answer as me. Don't just write it down. Pick up that calculator and multiply. You're going to take 15 sine 104 divided by sine of 47. And you should get 19.901. Is everybody getting that? Yes? Okay. So, what do I have this time? This time I have an angle, a side, and an angle. Angle, side, angle. That's another handy-dandy case that's super easy. Okay? So, I want x. X is across from the 42. So that means the x has to go under the sine of 42. Now, what am I going to do next? What's my next proportion I'm going to use? What side do I want? I want this. What side am I given? I'm given the 28. Do I know the angle? Can I find it? How? Right? So it's one of those, the very few times we're going to use geometry, right? All three of them have to add up to 180. So this side ends up being 75. So I'm going to have the sine of 75 over 28. And so again, it's just cross multiplication and divide. So multiply, make sure you came up with what I did. Did anybody not get this? You got it? Yes? Yes? Okay. So let's look at number 5. pilot begins a flight traveling 80 miles northwest. So he goes up here. To avoid a storm, he makes a turn and then returns to his original location. A diagram of his is shown to the left. Find the total distance. So first of all, to find the total distance, what's it asking me to do? What do I need to do? I only have 80. So what else do I need? Nothing? Right? I need this side and this side. So if this is 108 and this is 15, what does that leave for this one? All right. So which two do I have that are given? I need the angle and the side across from it. Which one is that? Do I know 15? No. Do I know the 108? No. Do I know the 57 and the 80? So that one I have to use as to start with. So I'm going to have the sine of 57 over 80. And I'm going to find x first. So I'm going to do the sine of 15 over x. So when you cross multiply, I get 24.689 miles. So then what am I going to use to find side y? Sine of what? What's across from the y? The 108. We're going to cross multiply. So am I done? Because what did it ask for? All of them together, right? So I need the 80, the 24.689, and the 90.720, and the total distance is 195.409 miles. Okay, so that easy peasy? Okay, so there is like one little wrinkle to it, okay? So the easy ones are the angle side and the angle side angle. That's when we just do this, right? But sometimes we're going to be given side angle. Don't spell it backwards because that's not nice. It's an unkind word. So don't be that, okay? We're not going to be that. We're going to say as side angle, okay? So if we're given side angle, it makes something called the ambiguous case. And I'm going to show you a quick little video. You're going to love it. It's going to be super fun. Joseph, do not go to sleep while I play my super fun video. You're going to like it. I think it does play a song. Wait. Shh, it's relaxing music. Shh, listen.
To see how that opposite side fits, we compare it to the height of the triangle. If it's too short, we can't draw a triangle, even if it's just a little too short. But if it's exactly the same size as the height, we get one right triangle. What if it's a little longer than the height? Then we can swing it to the right or to the left and draw two different triangles. A little longer and we still get two triangles until the opposite side is the same length as the given side. Now we can only get a triangle if we swing the opposite side to the right. Even if we make it longer, we can always swing it to the right and get one triangle.
Oh, but Jesus. All right. I don't. Not at all. All right. That's okay. I can live with that. All right. So, first of all, the sine function. If we're on a unit circle, the biggest the sine can be is a positive 1, and the smallest it can be is a negative 1, right? From either side, it's positive 1, negative 1. That's our sine value. The angles with the positive sine function, so if I draw this, these are the positive sine functions, so those are in quadrant 1 or 2. To find the other possible angles, we're going to subtract from 180 degrees. That's when we find our reference angle, right? The sum of the angles measure in a triangle. What did we say they all add up to? 180. And no two triangles can have two obtuse angles. If I added 95 and 95, it's greater than 180, right? So you can't do that. All right, so let's look at this one. So the first thing I have to do is I have to draw my triangle and then label everything in the triangle. So the measure of angle A is 60. AB is 30. And BC is 27. So the angle between the two sides doesn't fix the sides. It doesn't fix them so they can rotate back and forth. So if that's true, we can have 0, 1, or 2 triangles. Those are our options. So I'm going to show you how you find this. So first of all, we're just going to set up a proportion, okay? So I want to find angle C. So I'm going to do the sine of 60 over 27 equals the sine of C over 30. So first of all, now I'm looking for an angle. And when I have to find the angle, that's when I have to use the inverse sine. Okay? So in the end, we're going to have to use the inverse sine. So everybody get out your handy-dandy calculator and type with me. Take 30 times the sine of 60. And then divide by 27. Okay. Okay. Right. So now, what you're going to do, that number that's there, so press the shift button and the inverse sine, the inverse sine, and then next to the equal button, you push answer and push equal. You should have gotten 74.207 degrees. Well, any calculator can do it, and you have to, that's part of being in this class. You have to provide your own calculator. So, yeah, I did. Okay, so your phone should do it. Your phones do it. It does. When you turn it sideways, it says SINH. It does. Okay. Well, then get a new calculator. I don't know what to tell you. Figure it out. Okay. So listen. So now here's what I want to tell you. This is how we do this. So because because this angle isn't fixed, right? So this can swing either way. So I have to decide how many triangles I'm going to get. So once I get this answer, the first thing I have to do is take 180 degrees minus this number. And that gives you 105. So this is the first answer we got, and this is my second possible answer. So the way that I choose how many answers I get, the answer I got, which is 74.207, I'm going to add the angle that's here. What's the angle that's here? 60. When I add these together, I get 134. So is that less than 180? So this is one of the angles. So then I need to test the other angle I just got. So I just got the 105. I'm going to add 60. And when I do that, is that less than 180? So I'm going to get two triangles. I can use both angles. So angle C can equal 74.207 and 165.793. It can equal either one of them because it can swing this way and this way. So both of these work. So let's try the next one. So angle C is 89, AC is 34, and AB is 26. So we have the side-side angle. And so this is not fixed. The angle between the two sides isn't fixed, which means this side can rotate out or in. So what you have to do is I'm looking for angle B. So you have to test again. So I have the sine of 89 over 26 equals the sine of B over 34. You're going to cross multiply, and you're looking for the angle again, so you have to use the inverse sine again. So everybody try this and tell me what you get for angle B. What'd you get back there? What's your answer? Okay, so why is it error, y'all? What is your answer? It's not 0. What was on? It was like 1.3 something, right? So, but what's the maximum value that sine can be? 1. So this is 0 triangles. There's no triangles. It's too big. It won't work. All right, so let's do 8. So again, I have sides. They're not fixed, so one of the sides can rotate. So I have to decide how many triangles I can get. So I have the sine of 102 over 24 equals the sine of B over 21. So cross multiply, and what do you get for angle B? Mrs. Archer. It's okay. Right. So we get 58.857. Now, we have to check for a second angle. How do I do that? Okay, so I'm just going to take 180 minus 58.857, and that equals 121. So now I have to check and see if these are angles. So I'm going to take 58.857, and I'm going to add the angle I'm given. So I'm going to get 160.857. So is that less than 180? It is? Okay, but this is close, right? Okay, so that is an angle, correct? So next, I'm going to take the 121.143 and I'm going to add 102. Is that going to be less than 180? So this is not an angle. So I only get one triangle this time. I only get this one. I don't know why it's connecting the dots for us, but... So I only get one angle for angle B.